Good morning, mga Bisaya. So from last video, we discussed up to funding load. So in this video, we will be discussing the remaining three, or at least the remaining three loads, which is the wind load, the seismic load, and the crane load. Now, in wind load, we have two different um, method, or it's not a method, it's different what we call this one, types of wind loading. So the load that you use in designing the um lateral stability of your building, that would be under MW FRS, and then for the and of course the components and cladding. Now, so for example, if you have a building, uh, let's say something like that. You have, so let's just say for the sake of discussion, like just a simple one. So it will be like a box building. Now, if you design for example, say if this is a wood frame, uh, so if you design the shear wall, you have to use the what they call this one, MWFRS loads. And then if you design, say, the roof sheathing, the individual trusses, then you have to use the CNC. Now, in ASCII 7, there is a provision that if your tributary area, because there was a confusion, um, what load to use when you or what loads you're going to use for the trusses. Now, there is if you look at the AC7, it's not really clear, but there is, I don't know if you know about this one, but for wind loading, there is actually so for its edition of the, like for example, on this one, this is AC7 10. There is a guide um in addition to the AC7, like building code requirements, building load requirements. So this is a separate guide. This is more of like a commentary or a additional support for the AC7 itself, like the minimum what they call this one, the minimum. I already forget what's the AC7 is minimum design loads for buildings and other structures. And then this is a separate guide, just on top, or like a separate from the AC7 itself. So there is a guide to wind load, there is guide to seismic load, and there is also a guide to like snow load. Now, this portion here was taken from this guide in the frequently asked questions. So the question is, like the common question is, when is a gable truss in a house part of the MWFRS? Should it also be designed as a CNC? What about individual members? Now, read this, if you read this clarification, so there is this, it's a like um however, since the gable received wind loads from more than one surface, which is part of the definition in WFRS, an argument can be made that the total load of the truss is more accurately defined by the in WFRS load. A common approach to design the members. So this one. So a common approach is to design the members and internal connections of the gable truss for CNC loading. Now, so if you design the truss itself, like, sizing the members, that would be CNC loads, component and cladding loads. But when you design, or when you use the um or when you design the, for example, shear wall cross bracing, that would be the MWFRS loads. Now there is a limit, or I would say, with regards to the area, when can you apply an MWFRS in um, in a roof design. For example, this is common for a pre-engineered building. If you notice, in a pre-engineered building, right, that one, usually the frame is based, um in my experience, this is between 20 to 25 feet, 20 to 25 feet. Now the common span is 100 feet. So if you multiply, say this is a 20-foot spacing frame. So if you have a like a building like that one, and then you have the frame here, and then you have the frame like that one, and this is, say, 20 feet, and this is 100 feet. Now the tributary for this truss here would be half of that, half of that. So this is still 20 times 100, which is 2000, which is over the limit of 700 square feet. Now, in this scenario, you have to assign or design the frame. This portion here of the frame, you will design it as a, like, using the MWFRS load, because it exceeds the limit. Because the load, usually, for, like, in the way the loads are distributed over the structure, it's not actually um uniform, like uniform load. It's like varying load, like that, and then something like similar to like that one, and then they will just use average. That's why for bigger area, it is already like a safe to use average the average pressure, which is what is included in the MWFRS loading, like table, like for the pressure coefficient, CPCG. Now, if you design the individual members, like, for example, like purlins, or designing the attachment for the cladding itself. Now, because usually purlins are spaced, what, like 4 feet, 5 feet times 20, so that's only 100 square feet. So that is less than the threshold of 700 square feet. Then that means you have to design the purlins based on the CNC loading, like, uh, components and cladding. We will be discussing this in detail, like how the loads are applied once we um, touch the design, or the framing, like making the framing plans, the structural framing plans. But this is like more of an overview, like, what loads to be used in your calculation. Now, um, so yeah, like, if you have, um, if you have budget, you can buy this guide. I mean, this is really old. I have a copy of an old provision, but the latest, as far as I know, is S722, I think. Or is there like S725? Um, I think the last one I um because I'm a member of ECE, and then if you are a member, you will be allowed to have, or you can have like a benefit. One of the benefits is you will have a free like 10 webinar free each year. And then I think the last one I watched was I think 22, if I remember correctly. Say 7, 2022. So anyway, just make sure that that's the latest or whatever is the you know governing um, standard. For example, in the Philippines, the National Structural Code of the Philippines is, I think, because I asked my colleague, and he said the wind load provision is ASI 7 10. So just confirm with your local code which one is um, basically which code is being used i- i- like in your country or wherever you are in your jurisdiction. Now, yeah, like I said, we will discuss this in detail in the next video, and then yeah, just make sure that you read this part. When to apply the MWFRS, when to apply the CNC loadings, and then in my page also I um, posted like a design guide, um, like design load criteria for steel building. That was based on the NBCC 2025. And then as we discussed the when we touch the this portion here in the topic, this one here, we will be discussing um that design guide. And then the next one would be the seismic load. So for seismic loading, the most important, or I would say the first thing to do is you have to make sure that you identify the source of your seismic load. So use seismic mass source. Now, in different, for example, in this one, this is from NBCC, the National Building Code of Canada 2020. Now, if you want to see like the whole like building code, this is actually free to download. So Canadian codes are free to download, and make sure that when you download the building code, you also include the commentary. So for example, I will show you. Um, so this is the let's just say NBCC 2020, and then see this one. So you can actually download this for free, like the building code, and then make sure also that you include the commentary. Like this is the commentary for the structural portion of the building code, the part 4. So it will be if you need more information, this is where it's clarified, like all the um topics, or I would say, for example, let's try to download this one, and I will show you what's inside. I mean, if you want the printed version, then you have to pay. But if you want just the PDF, you can just download this one. So yeah, I don't know in other jurisdictions if their code I mean, for the like US code, I'm sure that you have to buy them. So, for example, this is just about part for the structural part. So it will be there will be clarification with regards to like this live load, snow load, rain load, wind load. So let's go to wind load commentary I, for example. So it will be like here where you will see the procedure, you know, like what to use. For example, this one, this is the if your building is if the height of the building over W is greater than 6, if that's yes, then you will use wind tunnel procedure. And then if the frequency is something like that, so you will just have this um like flow chart, and then until you like it will show you, for example, if height is 60, if the frequency is less than like 0.25 hertz, then if no, then if the height is greater than 60, then use internal or dynamic procedure. If no, then you can use static procedure. So something like that one. And then this will show you also like, which clause, which provision in the code, which part in the code that you can see the equations like that. And then it will, this is the description of, exposure factor, like if it's open terrain, and then there is rough terrain, and then there is intermediate terrain. So yeah, this is free. So if you want to, just familiar yourself with the building code, I mean, it's not the same as as a seven, but the idea is the same like the theory. So yeah, you can familiar yourself with this one. It's free anyway, so you just download it, and then yeah, so the first thing to do is you have to um, confirm with the code your jurisdiction is using, which, like, what are the loads being considered as part of the seismic load. So yeah, so usually what I did, or what I usually do is because this kind of you know um this kind of calculation is repetitive. Like every building you design, you have to calculate, or at least determine the seismic load anyway. Then I have created a like a seismic here. So I created a spreadsheet, and then yeah, there's no, this is in a, because I don't have a I don't have values yet for the specific location. But if I want to use this one, I will just use the user values, and then so yeah, this one is 0.025 of the weight. So whatever is the weight, say if your weight is like 1,000, then times 0.025, so that's your design base here. Now, what are the loads included in the weight calculation for seismic force calculation? So in, like, per NBCC 2020, that is the specified dead load, and then except that the minimum partition weight as defined in sentence need not exceed zero point 0.5 kPa. So this is where, like, I mentioned in the previous videos, that you have to make sure that you know what's the definition of partition load based on your code. Now, like I said, in BCC, partition load is considered as dead load. So since that is a dead load, then you have to include that in um, calculation for the base year, and then it should not exceed 0.5 kPa, which is 10 PSF, I think. 10 kPa to PSF 0.5. Yeah, 10.44 PSF. So that's your maximum partition load that you can consider as part of your, you know, weight in calculating the seismic force. And then there will be there will be 25% of the specified is no load. So you have to consider also 25%, and then 60% of the storage load, except that the storage garages need not be considered the storage areas and full contents of any tanks. So pag ano, if it is um, garage, like like in the storage area in a garage, then you may not consider that one. But for other storage loads, you have to use at least 60% for the weight, or 60% of the um, load used in it. So for example, you use storage load as a 250 PSF, then use 60% of that, and then add that with the dead load and the partition load, and the 25% of the snow load, and that would be your W. And then whatever is total value, then you multiply that by this 1.025. So that is your design base year. And then once you have the design base year, so this is your, for example, you have three-story building. So this is your design base year, then you have to distribute that over the height, and then you can design now your lateral force resisting system. And then yeah, so that's the um, crucial part. You have to make sure that what do you call this one, um you know which, like, what loads are considered as part of the weight of the building for seismic calculation. And then another thing also is you need to know if there are restrictions in your structure based on irregularity of your building. Um, Let me see. Let me just give me a minute here. Um, so this irregularity will tell you if you are, if you are allowed, or what are the limitations. So this one. So you have to check if there is any, vertical stiffness irregularity, weight irregularity, vertical geometric irregularity. Because if you are, for example, if you have vertical stiffness irregularity, then you have to abide by this provision here, like so for concrete and masonry shear walls, vertical stiffness or shall be considered to exist where the lateral stiffness of the is if RS is any story is less than 70% of the stiffness of the um uh just in story, or less than 80% of the average. And then if that qualifies, or if your building has this type of irregularity, then it will dictate, because some, for example, if you are using the equivalent static procedure, then there are limitations, what types of irregularity you can use. Now if your building is just, regular, like a box, the way I showed earlier, like just a box, then there's no irregularity, then you can use the equivalent static procedure. Now, if there is irregularity, um, you might need to use the dynamic procedure. So the last but not the least load is the crane load. Now, this is a special um, only for, like, if like industrial applications, if you have, like, if it's a shop or warehouse, something like that, and then you have overhead cranes. Now, if you are into cranes, there is a design guide, this one here. There's a design guide for, crane supporting steel structures design guide. This is the latest edition. This is from the Canadian Institute of Steel Construction. You can buy this one for $90. Um, I'm sure, like, in the US, they have also a design guide for this one. I'm not just familiar. Um, and there, I'm almost certain that there is in the American Institute of Steel Construction. There is a design guide for this. And now, yeah, so usually um, this is done by third party or like a specialty engineer. And most of the time, um, or not most of the time, always, when we have like a pre-engineered building, and if there's a crane, it's already part of their design. But um, for some reason, for example, if you are the engineer of record of a, say, warehouse, and then there's also a crane, then you will be forced to not design the crane itself, because, or I mean, it depends. Like here, the practice here is for cranes, they have um like what's the common cone cranes. So they design itself, and then they will just give you the loads that you have to apply. And now, before, I had experience with crane designs because we were the engineer of record for a crane manufacturer here, like locally. So I have to, design. I mean, I have to design the crane myself, and then apply the load to the buildings also, or design a freestanding support for the crane, for the overhead crane. Now, if for example, you are designing a warehouse, and then another, like, third party is doing the crane design itself. Sometimes, while you are designing the structure, there is no information yet from the crane supplier. So all you have to do, or in that case, what I usually do is I will design, or I will do a mock-up calculation for the crane, and then I will apply that to the um, as if I'm the one designing the crane itself, and then design the runway based on that one. So what usually, there is a recommended um, intract being used for particular types of, overhead crane. If it's underhung, if it's top running, and then what's the capacity. If it's 5 tons, there is this certain dimension between, the wheel of the intract, and then to the you will apply that to the what we call this one, to the runway. So for example, if this is your building, and then you have your column here. So you have your columns, and then you have the crane runway along this um that one. So usually, if this is if you're looking at the elevation of the column, so that's the column, and there will be like a profile here, and then this is where your runway sitting on top of the corbel. Now, of course, your crane will be running in this direction, like this direction, and then this is the crane bridge. And then at the end of the crane bridge, there is a what's called like an intrap. This one. So there's an intrap, and then what I will do is I will do a mock-up calculation of this one, and then I will determine the what would be the possible spacing of the wheels for the intrap based on the capacity. And then that's what I use to basically design this runway, apply that load as moving load. And then I will get the maximum reaction. And then when I design this particular one, then I will apply the load from the crane. Now, with regards to load combinations, because when you design the structure, you have to you have to use the factored loads, combination of all the loads. Now, I have here a load combinations from two different building code. Now, this is from AC7, the AC7-10. I'm not sure if the latest um, edition like changed their load combinations, but like like to be clear, this is from AC7 10. So just refer to your George, like whatever, wherever, like the jurisdiction. Just make sure you have your copy of your building code and then follow whatever is the load combination right dated in that particular code. Now the one on the right, this is from the NBCC 2020. Now for if you notice, you know both or the AC7 and the NBCC have different load factors. Now, for example, for dead load in combination with live load, you have the you have 1.2, right? But in the National Building Code of Canada, we are using 1.25 for the dead load. And then for live load, this is for live load, is 1.6, but in Canadian code, that's only 1.5. So make sure that whatever is the you know load factor used in your local building code, make sure you have to. I mean, you will apply those appropriate load factors. Now, going to the AC7 load combinations. So here, because in the US, there are states where um the snow is really, like for example in Texas, the snow roof no load is only 5 psf, 5 psf. But we already mentioned this in our previous video that there is a minimum of 20 psf roof live load. That's why in the load combination from the AC7 standard, there is a distinction between the floor live load and the roof live load. So roof live load is designated by L sub R. So that means that's roof live load. That's why this is the companion load, and you have to choose either roof live load, roof live load, roof snow load, and the rain load. I think R is rain load. Now, in the National Building Code in BCC 2020, the combination is different. So this is the principal loads 1.25 dead instead of 1.2, and then because in Canada there is no um, location where the snow load is less than 20 psf, then that particular load, roof life load, is no longer, like, basically disregarded, and it's always the snow load, because snow load governs. For example, in some locations, snow load here sometimes like 60 psf. Um, from where I am, it's 40 psf, so it's way double than the specified minimum roof live load. So roof live load will never govern. That's why it's not shown in the Canadian code. And then so yeah, right here you have R, which is rain load. I think R. Let me just double check if that's rain load. Uh, AC7 combinations. R. What is R? Yeah, so R is rain load, this one. R is rain load. But in the NBCC, rain load is already part of the snow load calculation. So in the equation, rain load is already part. Let me just let me show you. This is the let's go to snow load, which is where is it? Right here. So, and this is the roof snow load. So this is the importance factor. This is the ground snow load, SS, and these are all the exposure factor, the wind, basic roof snow load factor, the slope factor, and then this part here plus SR. That's the 150-year associated rain load in KPA. So the rain load is already part of this no load calculation. That's why you won't see rain load in this combination because that's already part of this no load. And then this table 4.1.3.2 dash B, this is where the if there is a crane in your um, loading. So I mean, all you have to do is basically add this 1.5 C, that's for the crane, and then, or is it crane? Um, load combination. C, 4.1.2, 4.1.2. So C is live load due to cranes, right? So yeah, so like C is 1.5 C in combination with just 1.0 live load, and then you reverse that one, the live load will be 1.5 in combination with 1.0 crane. So yeah, like I said, just refer to your local building code. Make sure that everything is the right load combination, load factor. So that's the um, most important part. And I think that sums up our loading. And like I said, in the next videos, we will be discussing more of this in detail as we apply all the loads for the analysis of the structure. So I think that's it for now. Yeah, so it's already almost 40 minutes. So in the next video, we will be discussing um, these topics here, preparations of structural plans. So I will be showing a sample of, I think I already shown it here. So for example, this one we will be, so this is our floor plan, and then we will try to do a floor framing plan, a roof framing plan out of this floor plan, assuming it's symmetric or typical from main floor and second floor. And then we will do a roof framing plan as if this building is, wood frame, or if this building is concrete frame, or if this building is like steel. So we will discuss the three types of materials, like common materials. Um, we will do like framing, like wood framing, then concrete and steel. So just like, overview, like what to consider. For example, if this is steel, we will be using composite metal decking, or over like open web steel joist. Now, if this is wood, then we will be discussing, floor joist, TGI. The common here is TGI, floor joist on engineered wood beams, and then or it could be like an open web floor truss, uh, open web wood truss. And then if it's concrete, of course, we will have the concrete beam and then slab. And then we will discuss, what to consider when you first lay out your framing plans and roof framing plans and floor framing plans. And then also the foundation plans. We will be discussing, what types of foundation. We will get a sample geotechnical report, and then we will read the report, and then see, what would be the recommendation, and then we will try to lay out possible foundation plan, like if it's, continuous footing, if it's spread footing, if it's grade beams on piles. And then after that, we'll be discussing these other topics here. So anyway, I think that's it for today. Um, yeah. So if you haven't subscribed yet, please subscribe. So it will affect the algorithm of our channel video, and then more, um, more engineers, new engineers will work and watch this video, and then hopefully it will help them as they start their career. So yeah, so till next time. Bye.